What's up, guys? Just wanted to check in. I know we needed to get a point slope video in, so we're about to do that. So basically, I just want to give you the gist of it. So point slope is the same thing as graphing a line using slope-intercept form. It's just a different form. It looks different. We can always talk about that. Things just look different. So a point slope equation has a point and a slope. And it can be any point that's on the line, whereas slope-intercept can only have the slope and the y-intercept, which is when x is 0. So technically, you could write point-slope form using slope-intercept. You would just plug in your slope and then your 0, comma, whatever for your point. But when you do that, it's going to cancel some stuff out, and it's going to look like a slope-intercept form equation when you solve for y. So point-slope is really helpful when you know, like, okay, after working 8 hours, I made $100, and I know I get paid $15 an hour now. I can write the equation to figure out how much I'll make in 30 hours or 40 hours. Or really good for like distances, when like, okay, I'm driving at 55 miles an hour, I've been driving for 7 hours, I've went 300 miles. How long is it gonna take me to get to, something 500 miles away? So y minus y1 equals m times the quantity x minus x1. Y1 and x1 are just coordinates for your point, and slope is just your m. So I'm going to show you how to do some of that in just a moment. Alright guys, so I've been meaning to get you this video, so here we go. So you should have this sheet, writing point slope form, and it's a double-sided sheet, so we're going to go through it. So basically you have the formula for point slope, and it's y minus y1 equals m times x minus x1. Now we already know that m represents slope. That doesn't change. So m is your slope, m is your rise over run. That's going to be on that right hand side next to the x and the x minus 1. Now what's different with this one is the y1 and the x1. So it's minus x1 and minus y1 is always minus whatever the x1 is and minus whatever that y1 is. And that x1 and y1, they make up your ordered pair. They make up your point. So the reason it's called point slope form is because you have a slope and you have a point. And let's say it was just 2, 4, it'd be x minus 2 and y minus 4. So whatever the x is and the y is goes into the formula. So that's the only difference between this and slope-intercept form. Stop it. So if you're looking at this paper, basically the idea is, can you write the equations, can you use it? So it says, what is the equation in point slope form of the line that passes through the point 324 and has a slope of negative 0.06? Negative 0.6. So what you got to think about is what's your x1 and your y1 and what's your m. So I'm going to label my 3 as my x1, I'm going to label my 24 as my y1, and my negative 0.6 is my m. So you want to have those things labeled, and then you just plug them in. And again, we substitute using parentheses because that makes things work out nice, especially with all these negatives. So we got y minus 24 equals m, and m is negative 0.6 times x minus parentheses 3. So when you first set it up, you should have something that looks like this. We got the x1 and the y1 in parentheses, just because if those were negative numbers, we want to be able to know that subtracting a negative would make a positive. Okay, so you're here. We have our x1 and our y1, we plugged it in. We use parentheses because if that was like a negative 24, you know that a y minus a negative 24, you gotta add the opposite. When you remove negative people, it makes your life more positive, so it's gonna be y plus 24. It all depends, so we use parentheses. Now, I'm gonna simplify this. It's gonna be y minus 24 equals negative 0.6 times x minus 3. That is the point slope form equation. Now, you should notice that you could do distributed property and you could get YL by itself. If you do that, you will end up with slope-intercept form, which is what we've done many, many times. Stop. Alright, so this next problem, you're given a table and you have to write 4 equations. So what you gotta do is label your x1 and your y1. So for the first one, it would be negative 4 and 13. The second would be negative 2 and 8, but you gotta find the slope. So you have to do that by finding the common difference. So we look at our x's and we see that we're adding by 2 every time. So the x's are increasing by 2, that's our run. And then we gotta do the same thing for y's, and it looks like we're going down by 5. So we know that our slope is rise over run. It's gonna be negative 5 over 2. So that slope is gonna be the same slope for every single equation, all 4, but the x1 and the y1 will change. So I'll write the equation for the first one, and then you guys can do the second and third and fourth. It's gonna be x1 and y1. X1 is your negative 4, y1 is your 13, and then we plug it in. So it's gonna be y minus my y1 is 13 equals, my slope is negative 5 over 2. We got Talia on the camera, by the way. And then it's x minus a negative 4. So we're gonna simplify that to a positive 4. We get y minus 13 equals negative 5 over 2 times x plus 4. If you wanted to, you could definitely go ahead and solve this for y to get slope-intercept form. So we're going to do that by doing y minus 13 equals negative 5 over 2x, multiply that, plus, minus 20 over 2. Y plus 13 on both sides. So it's going to be y equals negative 5 over 2x. And that'd be minus 10, so it'll be plus 3 after we simplify it. So that's the whole idea. Get point slope when you need it, simplify the slope-intercept form when you don't.
Talia was little, we had like 3 of those, and now this time we're like,
Look at the coordinates, find the slope, use a rise or run, plug them in. One. Given the equation, so you find the point, looking at the x1 and the y1, find the slope, and then you just graph it. So you see I started here. And then I also went up 2 over 3 because that's the slope. You keep doing that and you got your line.